So hi, just a quick heads up, this was supposed to be a repair video, but instead you get to see me trying to figure out how to use a bit of vintage kit so I can just check out that it works okay. So hi everyone, today on the bench I have got this device here, and this is a Marconi 110 MHz Spectrum Analyser number TF2370, and this is in two parts, a display unit and the analyzer unit. And these are quite desirable items. When I was quite young, that's quite a few years ago, I wanted to get hold of one of these, but I could never manage to afford one at a price that made any sense. And they're still quite desirable on eBay and things like that. Now, I don't know whether this one works at all. I suspect it doesn't. And it may well be that the amount of work required is more than I'm willing to invest, because I can pass this on easily as a for parts device, and only for a little bit more money if I get it up and running. So the amount of effort I'm willing to put in is, you know, a bit, but not a lot. But anyway, we'll have a look at the repair. Now, before I get started with that, I would just like to say a thank you to all the people who have subscribed. Finally, I've got over 200 subscribers. Now, I am aiming, of course, to have 1,000 subscribers so I can become a YouTube partner and start earning some money to pay for all of this stuff that I'm putting on my bench. So it's not free, and you know, anyone who subscribes, I'm really, really thankful, because it does help me get towards that target of being able to do more repairs, and actually repairs on more interesting things that are a bit out of my price range at the moment, because of course I'm self-funding all of this. So anyway, that's the begging over. Please subscribe, and I'll move on and let's look at the device. So I've already tested the fuses and they're okay. I've checked the voltage, that's okay. I just now need to find a power cable that will do the job for me. The observant of you might notice that this is not on my bench at the usual angle, and that's because it's a little bit big, and I needed to do some connections around the back. Let me just pop the camera off for a second and I will show you those. Okay, so here is the handheld back view. So the top unit is the power, takes the power in. It's set to 240 volts over here, and here are all the big power transformers, because this is going to produce the power for the bottom unit as well. There's no separate mains lead for that. There are, however, these huge braided interconnects, and I was really pleased to see that these were present. Occasionally you see them without them. Or you'll see one of the units and it hasn't got these connections. So those are really important, because obviously they are both data and power between the analyzer and the, well, I say data, signal and power between the analyzer section and the display section. So anyway, I just needed to have access to deal with those. These do interlock, and you see there's like clamps to hold them in place. I haven't fastened those up because I'm almost certainly going to be taking this apart again before long. Okay, first of all, got to turn it on at the power. And okay, well, we have a reading, at least. Over here we have something on the display. I'm just going to turn one of the lights off just to hopefully make that a bit easier to see. I don't think that made it easier to see. Let's turn the other studio light off. So this is obviously the attenuator down here. So we'll pick 0 dBm. 1 dp per division, vertical scale. Yeah, well, I don't know. We need to pick something. So we are nowhere near the top of the screen at the moment. We do have intensity, and we can kind of, I don't know if it shows on the camera, but there are scan lines across here. Sweep mode auto, that sounds alright, doesn't it? Okay, so I have it turned on, and I'm going to just adjust its angle in a second or two so I can see it better, but at first blush it looks like something is working, at least. So this has a tracking generator, but I'm not going to use that for the minute. What I'll do is I will just find a long enough BNC cable if I can. That should hopefully do it. I'm going to need to make up some more BNC cables. And I've got a 120 megahertz generator, arbitrary generator. It shouldn't really be doing anything yet, but anyway, we'll see. Cool, excellent, that looks pretty good. I'm sitting on the instruction manual, that doesn't help. Okay, so I've got this turned on. There's a little bit of a hum, which is annoying, but other than that, I'm not too worried about that. And I have a 50 megahertz minus 25 dB signal coming in on the front end just here, which is a sine wave. Now, intensity A seems to work fine. I can also display B, and that is actually a stored signal, because this is a storage device. So intensity B also does vary quite happily. Doesn't go as high as intensity A, but you know, that's fine. So there's intensity A, and here's a stored signal coming up behind in grey. So that's cool. Let's turn off B. So we've just got A, and we're storing into A. I have no idea how you kind of go from there. And this is just high definition mode. I have no idea what that is either, but I can read about that later. Bright line position, don't really know what that's doing. I'm not using bright line anyway. So, counter frequency past center or difference. So I'm not interested in difference, I'm going to go for past center. Reference frequency center. So let's turn up the, so I've got 43 here. These are all, I've turned all of these counterclockwise. 49.3. 8. Go on, you can do it. Stay still. There we go. So I've got a 50 megahertz center frequency set up, and just here I've got a spike at 50 megahertz. Let's turn off my input just to, there we go, it's gone. There it is. Okay. Now there's quite a lot of spurs on this, and there's obviously quite a lot of noise on it, but I would have to say generally that's working now. Let me have a look at horizontal scale. So I'm on megahertz per division at the moment. How is that? Do I know how I'm on megahertz per? This is a filter, so let's put a narrow filter in. So with narrow filter, it's drawing a lot slower. I don't know if you can kind of see that easily on the image. So I'll go for a wide filter, which would be, it did stay in, sort of the survey speed. I'm going to go for normal. Now here's the range, megahertz per division or kilohertz per division. So if I go for kilohertz, then I should get a much tighter thing, but my position has moved. I'm beginning to get used to the controls a little bit, but it's really weird having analog controls. So kilohertz, we've got 5 kilohertz per division with a 500 hertz bandwidth filter. Okay. Might just need a bit of cleaning, to be honest. In fact, it almost certainly does need a bit of cleaning. So here we go. We've center frequency 49.97, and our 50 megahertz signal is about to come on the screen. There it is. Let's see what the frequency counter says when it hits center. Should say 50, of course, but you know, who knows really. look at this. Look at that. 50 megahertz signals generated, and that is accurate, and it's satellite locked and all that sort of stuff, GPS locked, and we're smack on 50, and that's with its internal crystal. So bloody fantastic, and that's pretty stable as well. I mean, we're moving by maybe 10 hertz, something like that, but that might just be that I just need to tweak this. An easy bit. Okay, cool. So I'm not used to using 4 controls to manage the frequency on here, but there we go. Center frequency 50. Let's try and see what happens if I press 2 on here, because this should give me 2 kilohertz per division, still centered on 50 hertz, with a 50 hertz bandwidth filter applied. There it is. How's that? And let's so this is a video bandwidth, isn't it? So let's change our filter bandwidth to narrow. This is a slow paint now. I think that click there is where oh, look at that. Absolutely perfect. And then we are 2 divisions down from the top of the screen. So let's see if we can work out what that means. So my datum is set at, I have no idea. Let's have a look at what I've got down here. This has got a attenuator on it, so let's turn that off for starters. So the noise floor has just dropped. So I am on dBm just here. So I'm on 10 dB per division with a top at -20. Yeah, 10 dB per division over here. So 10, 20, 35. This is the vertical range. That picks the light on here, and then we look along here and we say, what is the datum top of the screen? So I'm going to pick -20, and we've got 10 dB per division. So for a -25 input signal, have I got -25? Yep, I have. I would expect that to be higher. So let me get my other frequency generator going, which can generate slightly higher dB outputs and is probably more reliable. I'll get my power meter going as well. Okay, so I have connected a different signal source, which I've just checked on my RF power meter. So it's outputting 50 megahertz still, and or thereabouts, and it's actually running on an internal oscillator, not a frequency lock, so it could be a shade out on here. And I have it set to 0 dBm exactly, and if we look on here, if I put 0 dBm, I get, I've got 10 dB per division, and I'm saying the vertical scale, dB datum at the top of the screen, is 0. So I should expect that little peak just there to be on that top line, so about a centimetre above where it is. Now, if I say, so you would say, oh, well, that must be -10 dBm then, because it's 10 dBm per division. And there we go, we're 1 division and a little bit down. So if I put in -10, I should move up to the top of the screen. Well, I don't, I only move about 0.4, so I'm still 0.2, 0.4 down. Now we do have a gain adjustment here, so we can have a little play. I'm hesitant to do too much with it though, because you would think that that would change the scale rather than its position, but yeah. The main thing we're getting here, we go to there, which is pretty much where it was before. And we're just clipping at the top there. So I would expect the data at the top of the screen to be 10, and that should be 10 down. Can I adjust it now? Yes, I can. Right. So that is reading correctly now at 0 dB. Let's put in minus 20 and see what that does. So it won't be exactly minus 20 because this frequency generator isn't quite there, but so minus 20 dB. And yeah, we're not bad now. Now I just need to adjust the gain down a shade on here then, because that has some of this is to do with the resolution. So plus 10, 0, minus 10, minus 20, so that's looking good. Let's try minus 40. 0, 10, 20, 30, 40. Yeah, we're just flipping up there. It's just kind of not very sensitive at that point. Tiny little bit more gain then maybe. And a tiny little bit more gain on the screen. And I think we're there. So if I do plus 20, of course, yeah. Minus 30, I'm on minus 40 and I'm about 10 down. So yeah, I'm pretty happy overall. So this thing should go to 110 megahertz. I'm going to feed in a 100 megahertz signal now. I'll say at, I'll do minus 10 dB. Yay! And 100 megahertz then. Carrier frequency 100 megahertz. Should now be off the screen, of course. Let's see what happens if we wind this up to 100. Hopefully we'll be. So what's my horizontal scale? Yeah, I'm going to go for 1 megahertz per. So I'm pretty close at that. 99.98. Whoops. 99.95, 96. That's pretty bloody good. And dB right reading is correct. Let's change the filter to normal. Yeah, so actually we've got a tiny bit of gain on there and narrow. Nice. And let's see if I remember what to do next. So we just need to trim that up a little bit. There's our center screen, basically 100 megahertz, 100 megahertz. Minus 10 dB, minus 10 dB. Yeah! Bloody hell, it works. So I'm just going to do a tiny little bit of cleaning up, and I'm going to list this on eBay. So I haven't tested it entirely, of course. I should just check the tracking generator, shouldn't I? That's a 10 megahertz standard out. Cool, I reckon they're going to be pretty clean now. On the inside at least. Oh, there's one lucky connector. I think that'll give a much better connection. Let's have a look. Nice. I don't know for certain, I would have to compare the video images actually, but I'd say that's probably less noisy. 20, 30, 40, 50, 60. So the noise level is about minus 70 dB on that, which for this age of instrument I'm not thinking is too bad. And yeah, we've got a narrow bandwidth filter. What's our width here? 0.2 is it across there, I guess. Let's try 10 megahertz per division. So the noise floor goes up as you would expect. Yeah, and there we have it. We'll go for a normal filter there. Yeah, higher. So essentially reducing the bandwidth, of course, should reduce the noise floor a little bit. Let's go for a bandwidth of 1. Yeah, there you can see the noise floor just drops out. Bang, and there's our peak. The frequency shifted just a teensy bit there, but nothing much. So what's our noise floor now at this sort of slow scan rate? So we've got plus 10 on the top. So 0, 10, 20, 30, 40, 50, 60, 70, 80, minus 80 dB noise floor there. Yeah, nice. Obviously we can probably go lower than that. That hasn't really brought it down a lot, just a teensy bit. And we're actually seeing the skirt on the frequency now, so 0.02 megahertz per division. There you go. And if I trim this in, try and trim this in. There we go, 100 megahertz center, and this 100 megahertz input signal is on center. Beautiful. Yeah, and yeah, easily coming out the minus 80 dB floor. Let me put a minus 50 dB signal in just to check that. RF level, minus 50. There you go. Minus 50. Beautiful. Okay, cool. So I need to do another little test which here relates to the output here, which is supposed to be 10 megahertz output, and the tracking generator as well, because this does have a tracking generator, which I personally think should be fitted as a matter of standard on every spectrum analyzer, but it seems manufacturers like to charge more for it, to be honest. And the thing is, of course, for the tracking generator built internally at the time of manufacture, I mean, you've already got most of your circuitry there in all your IF sections and everything like that. So it's disappointing to me when they don't put it in. So yeah, okay, so the tracking generator is supposed to be a minus 10 dBm signal. And there it is, right there. So let's give ourselves a nice wide bandwidth. Yeah, we've got a minus 10 dBm signal there. I don't think I've got anything filter-wise that I could kind of connect up that's particularly obvious that I could connect up, so to speak. So let's see what we've got. So I've got a center of about 100 megahertz, and I've got 5 megahertz per, so 5, 10, 15, 20, 25. So we're up to 125, so off scale, really just here, which is where that peak is. And on the left-hand side, yeah, running down to 2, 3, 4, 5, 6, so 30 meg below there, so 70 to 110 is what I'm scanning at the moment. I'm now doing 10 per division, so really I should turn my frequency down to about 50 megahertz, I suppose. There you go, center of 50. So we've got a little bit of noise down here, which will be where we bottom out. 49, 48, so 50, 50, 40, 30, 20, 10, 0. So yeah, this is our DC point, just on the left-hand side here. Excellent, superb. And let's give ourselves a 10 megahertz output, which is also minus 10. And we should expect to see a comb, which is exactly what we do. Yeah. So the comb is 10 megahertz spaced out, and we've got a 10 megahertz spacing here. So everything is good. Yeah. I'm very, very pleased with that. So the tracking output works the tracking output works, the standard calibration comb works. Everything's there. Spot on. Okay guys, so I suppose that's about it. So on the screen at the moment I've got a square wave coming in at 10 megahertz, which is this line on the left hand side, and then we've got all the odd harmonics showing. This harmonics is not showing very well because it's actually exactly on one of the graticle lines, but so anyway, we've got 10, 20 is missing, 30 is there, 40 is missing, 50, 60 is missing, 70 is there, 80 is missing, 90 is there, and 110 is kind of lost in the noise floor there. Because I've got a very high bandwidth, so the noise floor goes up because high bandwidth equals higher noise. So anyway, there we go. That looks pretty good. So I'm not going to do any more refurbishment on this. The main reason this is on my bench today, that I picked it off the pile, is because I need to move some stuff out the lab. So I need to kind of get them refurbished on eBay, etc., etc. Now, if I was keeping this, I would go through and refurbish it. I would clean all the buttons, all the controls, everything about it really, but I think that whoever buys this will be pretty happy with the condition that it's in. They might want to go through and do some of that, just take some noise out the controls and things, but overall, as far as I'm concerned, it's working. I'm not going to test every single range and everything about it, but I don't see much value to me now in actually going through and doing stacks and stacks and stacks more work on it. You know, yeah, okay, if I did that, I might be able to make the listing a bit more glossy and a bit more pretty and make a few more pounds. But overall, for the electronics enthusiast, this is the business already. So let's just go with that. And I get a few cubic feet back in my lab. So anyway, next job is to list this. So I'm sorry there wasn't a repair involved this time. I'm very surprised that I just took this, plugged it in, and it worked. I really didn't expect that. But you know, sometimes you get lucky, I guess, and unlucky in this case, because obviously I wanted to show you a repair. But anyway, you know, hey. So hopefully you enjoyed it anyway. It's always interesting, I think, to look at a bit of vintage equipment like this. Perhaps it's probably more interesting watching me struggling trying to work out how the hell to operate all of these buttons. I'm not used to that. Used to little menus with buttons and touch screens and things, much easier. But anyway, vintage equipment, vintage operating fingers, and we are up and running, ready to go. So hopefully you enjoyed it. If you did, please give it, you know, like, thumbs up, whatever it is, and yeah, subscribe of course if you haven't, just like I said at the beginning of the video. I'll see you next time. Hopefully we might get to repair something or make something. See you soon.